Hi everyone. Today we're going to be learning about balancing equations, which hopefully is a review for you. I'm just going to shut my volume down. Hopefully a review for you, and then formula and molecular mass, and those will be new concepts for most of you here. So this is going to be, lesson 2.3. Okay, we're going to take a look at balancing first here. So when balancing a chemical equation, you have to have the same number of each type of atoms on each side of the arrow here. So this is just an example here. So we've got our arrow here. So that means on both sides of these, I need the same number of hydrogens and the same number of oxygens. And we just have this little scale image here to show that they have to be equal to each other. And so what you do is the molecule is written as is, and then we use these, which are called the molar coefficients, or you can just call them coefficients, and we use that to balance our equations. And like I said, this should be a review for all of you here. So the order for balancing, now this is something that your teachers last year may not have gone through for you. Typically, it does go better when you balance the metals first, followed by the non-metals. So the metals are on the left side of the staircase on the periodic table. The non-metals are on the right side of the staircase. And then do hydrogen, followed by oxygen. Okay, so we're going to go through and balance this particular equation. Now, some of you in your grade 10 year, you probably set up a chart underneath your equation. I would get away from that. Try to keep it in your head, just because as we move forward in chemistry, you're going to be doing this a whole lot. And basically, you just want to try to keep it in your head so that you can move faster. So looking at this one with the tin oxide here, if we follow our rules here, we're going to start with our metals first. So I've got one tin here and one tin here. So good, they're balanced. Now I want to balance any non-metals. Now, non-metals, obviously we have hydrogen and oxygen, but I'm going to consider those separately. So then hydrogen, I've got 2 here and I've got 2 here. Good, balanced. But oxygen, this is where we have our problem, right? I've got 2 oxygens on the left-hand side, or the reactant side of the arrows, and I've only got 1 on the other side. So I'm going to use the coefficient 2 here, but when I did that, I messed up my hydrogens. So now I've got 4 hydrogens. So this is 4 hydrogens here. So that tells me I'm going to need a 2 there to balance off the hydrogens. So as you can see, this equation is now balanced. You always should do a quick double check of it, but that is correct. Okay, so we're going to do this one. And so I would pause the video right now and try this on your own, okay? Okay, so hopefully you've paused it and tried it. I'm going to go ahead and balance it now for you. Now again, we're going to balance our metals first. So I've got my arsenic AS, and I've got AS over here 1 to 1, so good. Next, I'm going to look at my sodium. So sodium, I've got 1 here, but I've got 3 here. So I'm going to put a 3 on that one. Now I'm going to look for hydrogens. I've got 3 hydrogens on the left side, okay, because that 3 applies to the hydrogen here, and I've got 2 here. So that's a problem when you've got 3 on one side, an even number on one side and an odd on the other. When that happens, we often will try doubling things. So I'm going to go with 6 here instead, and I'm going to put a 3 here. Now, because I put that 6 there, I've now messed up my sodiums though, right? So now the hydrogens are balanced. I've got 6 on each side, but now my sodiums are messed up. So now I've got 6 sodiums here, so I'm going to put a 2 here. And now though, my AS is messed up, so I'm going to put a 2 over here. And now I'm going to double check my oxygen. I've got 6 on the left side, 6 on the right, and it is done. So my coefficients are going to be 2, 6, 2, and 3. So you get lots of practice doing that. You just need to practice balancing, and then it's a skill that you develop like anything else. Next, we're going to talk about formula and molecular masses. So just a quick review: molecular compounds. These are atoms. These are compounds when we have atoms that are linked together by a covalent bond. And so covalent bonds, of course, we're going to be sharing electrons, right? and these would be with the non-metals. Now, the mass of the molecule is called the molecular mass, and sometimes you'll see that abbreviated MM. So an example of this would be things like carbon dioxide, oxygen gas, iodine. All these things are going to be all molecular compounds here. Now, ionic compounds, these are composed of ions. So the mass, when we add up the masses of these, we're going to call those formula mass, so FM instead of our MM here. Example, these would be things like NaCl, lithium fluoride, etc. Okay. So we've got ionic compounds and molecular compounds. How we calculate the masses is exactly the same way. We just literally, one's called formula, one's called molecular mass. So, okay, we're gonna go through an example here. So to calculate the molecular mass of C9H8O4, so you're gonna need your periodic table for this. And so this is a molecular compound. So molecular mass, let's just go through. So how many carbons do we have? 9 carbons plus 8 hydrogens plus 4 oxygens. So we're going to use that information. We're going to use our periodic table to add them up. So 9 times 12 plus 8 times 1.01 plus 4 times 16. So we use our periodic table for that, and then we add them all up. My calculator just died. Look at that. Okay. Okay, and we end up with 180.08. So don't worry about sig figs here. You want to just keep as many digits as you have for whatever periodic table you're using. So these are all the masses from the periodic table that I'm using, so the atomic masses, and I'm using those and adding them up. Now, what is the unit going to be here? Yeah, so AMUs. Whoops, no S on it. So AMU, so 180.08 AMU. Now, I'm going to try this one on your own here. So calculate the formula mass of magnesium chloride. So for this one, you're going to calculate it exactly the same way. You're just calling it formula mass instead of molecular mass. So the formula mass is going to be equal to 1 atom of magnesium plus 2 chlorines. So we've got the magnesium, which is going to be 24.3, plus 2 times the chlorine, which is 35.5, and we're just going to add those together then. So 24.3 plus 2 times 35.5, and so we get an answer of 95.3, and the unit, atomic mass units. Okay, so example, here's a little question for you. How many atoms of each type are in a molecule of barium nitrate? Now, to do this question, you need to know how to name, right? If you don't know how to write the formula for barium nitrate, you're not going to be able to do this problem, right? So right away, barium, I know, has an ionic charge of 2 positive. The nitrate ion is 1 minus. So when these two things bond, I'm going to need 2 nitrate ions, polyatomic ions, to balance off that 2 positive for the barium. So how this is written, use the brackets, and then we have a 2 on the outside. Now, how many atoms of each type? How many bariums are there? 1. How many nitrogens are there? This applies here. 2. And what about the oxygen? It's going to be 6 atoms of oxygen, okay, because we distribute that out. Sometimes people get confused and they put 5 there, but it would be 6, so 2 multiplied by 3. And if that's confusing for you at all, just go back to this, because it's pretty clear here that you've got 6 oxygens there, okay? Good. And so when you are calculating the molecular mass of this, let's just do that. You're going to take 1 barium plus 2 nitrogens plus 6 oxygens, and you're going to add them all up. So you can do that on your own, just using your periodic table. Okay, your assignments here are exercise 6 and 4. So exercise 6 is the balancing. So quite honestly, you don't have to do the whole thing. It's sort of like if balancing is easy for you, I would only try a couple of them. And then exercise 4 is about the formula molecular mass. And again, that's a very short assignment too. So this assignment really shouldn't take you very long. Okay, thanks everyone.